I've started streaming now because I want to check that all the audio and video is being done properly.
Perfect. I'll flick on my camera there for a second, actually. I'm in my car. UCC Canoeing is like UCC's Canoeing is having their first meet for refreshers, so I said I'd pop down. But that also does mean that I am doing this in my mom's Fiesta, so we'll see how that goes. I'll see how the camera goes. If I go really robotic, I might have to turn it off, and I'll flick my mic on and off if it gets annoying. But we'll see how we go anyway. We're taking it on tour today.
I hope this means that you are not doing the driving.
Oh, anyway, we'll see how it goes. Could you imagine? I should have had it streaming. I would have been driving, listening along. Anyway, we'll see how it goes.
Okay, so I'm looking at the stream and I can hear and see, so that's good. So we'll wait for everyone else to stumble in.
We'll give it 2 more minutes. Yeah, give it a couple of minutes.
So, what about? We got any nice scenery we can see? Are any cows or horses?
I'm at the bridge now, so this is what we're seeing. Yeah, Yawl is what Mom's saying we're in Yawl. I'll keep you updated as this goes along. I couldn't see any other way of doing it. Like, and I didn't want to cancel it because I don't know what's going on. So we'll do it in the car. If I get really annoying, tell me to shut up. If it gets really robotic, I'll be quiet. Same way as which I'm on my data, so I won't share my screen as much. Maybe that'll stop the robot voice. But it's a trial and error here. So tell me if it gets really bad and I'll stop.
Yeah. To be honest, I mean, I have to say, it's actually sound quality, anyways, is marginally better than you're getting at home, which says something very sad about the state of Ireland's infrastructure. Because my housemate does the same thing when he's got a very large file to download. He doesn't use the broadband, the landline broadband. He uses his phone, because he gets speeds which are so much greater, and it's stupid, really. But
it's just easier at this point. I used to have really good Wi-Fi, but it's after going down the drain ever since I got home from Cork, and it's just I had to get data last week because it kept like buffering during Teams. I was petrified it was going to happen during the geology exam. I had to rush over to Centra and go nab some credit, but it's working out. So actually we're doing quite well. It's 3 minutes plus. Man was pointing out the scenery again. There's a guard apparently across the side of the road.
That's okay. You can do what you like as long as she's concentrating on her driving. We're fine.
She'll narrate it as we go along. That's the numbers are kind of steadying out now. So I might share it from my screen. I might share it and then just read it out and stop it again. I'm so worried about it buffering. Okie dokie. Now hopefully this will work out. So, question 1, milk in your tea. So in this problem you'll find out what happens when you add hot tea to cold milk. For simplicity, assume that the specific heat capacity and density of tea and milk are the same. Remember, a litre is equal to 1,000 cubes, equal to 0.2. Is it? It's not. It's 0.001 meters cubed. So if it's 0.2 litres of tea at 85 degrees Celsius is added to 0.03 litres of milk at 5 degrees Celsius, what is the final temperature? Just a quick warning, I wasn't doing too well with the thermodynamics and chemistry. It's not going any better right now. So I've attempted them, they haven't gone out well. I had a quick look at the notes that Paul gave, and I just presumed for this one that it was the heat loss plus the heat gain equals 0, but I didn't
Yeah, I had a look.
know because there's
And she's gone. I had a look back through the notes and couldn't find.
no specific heat capacity, so I presume that was wrong.
I couldn't find anything useful in my notes, which probably says more about me than about the notes. But my friend Google helped me out tremendously here. I did get an equation for working out such things. The equation basically amounted to you take I think you're you might be between mobile towers.
The robot voice has taken over.
The equation I found was you take the amount of T, you multiply that by the temperature of that T, you add to that the amount of the milk times the temperature of that milk, and then you divide the whole lot by the total amount of liquid that you've got. So in the case of question 1, you've got the 0.2 litres of tea times the 85 degrees centigrade plus the 0.03 litres of milk times the 5 degrees centigrade, and that's all divided by the 0.2 plus the 0.03. And when you work it all out, it came out for to 74.6ish degrees centigrade. Now I sort of, because I this was just an equation that I got off the internet, and such things are never to be trusted. I then did the calculation again with all the units in it, just to make sure that what I was getting out at the end was what I was looking for, and it did come out to be just degrees centigrade I was getting out at the end. So I was happy to go with using that equation and using that answer. So whether or not there's that equation in the notes in that sort of format or a slightly different format, I don't know. Probably there is, but yeah, it was the amount. So the weight, the mass, or the volume of the tea times the temperature of that tea plus the amount, the volume or the mass of the milk times the temperature of the milk, and then all divided by the total amount of liquid that was there. So the mass or the volume of the tea plus the mass or the volume of the milk.
Sounds fab.
Did anyone else actually find
it? Does, yeah. Now my robot.
Did anyone else find an equation out of the notes for that one, or?
I'm a little bit behind in lectures, so I'm not really too much help there.
All right, okay. Well, like I say, I did double check it with the units, so I'm confident in using it. Whether or not you want to trust me there is entirely up to you. Do you trust this face?
The answer's down anyway.
You're doing better than me anyway.
So question 2, in the absence of our friendly robot, that was the mobile phone one. how much energy a mobile phone transfers to the user. We were given a piece of interesting but completely, I'd say, irrelevant piece of information about European regulations. Then the relevant information we were given was that to assume that a mobile phone radiates energy such that each kilogram of tissue near the ear receives 1.1 watts of power. Assume that this energy is used to heat the tissue. And we were asked, in 1 hour of mobile phone use, how much energy does it deposit per kilogram of tissue? So I just completely ignored all this stuff about kilograms of tissue and so on. So we know that 1 watt is 3,600 joules per hour. Luckily he wants to know about an hour's worth of mobile phone use, so as I say, 1 watt, 3,600 joules per hour, so 1.1 watts is 3,600 plus 360 joules per hour, which is just 3,960 joules per hour, and that's what the question's asking us. How many joules? So 3,960. Simples.
Good. Actually, I tried to. Yeah, that's not so much easier. I was using the power is equal to energy over time, but it just seemed incorrect. It seemed wrong. Like it just didn't look right. That's it. That sounds right. Okay. So it's just the 1.1 by the 3,600, which is the joules. Yeah.
Well, yeah, but as I say, that was only because he was asking us for 1 hour. So I thought, well, let's keep things simple.
It makes sense.
And then for the for the second question there, second part of the question, the specific heat capacity, what increase in temperature for the tissue in your head. I used the formula C equals Q over M times delta T. So C is the specific heat capacity of the material. Q is the number of joules that are actually being used, gained or lost. M, mass, and delta T is obviously the change in temperature, and it's the delta T that we want out of this equation, the change in the temperature. So again, it's just a question of plugging the numbers into the equation. So C is the specific heat capacity we're given, the 4,186. Then we've calculated the Q, that was the previous question, so that's the 3,960. And then again, mass, we're gonna just take 1 kilogram because we can, and the number 1 makes calculations simple. So it's 1 times delta T. So we can effectively get rid of the 1. We don't need it because 1 times anything is the same answer. Plug all the numbers in, work it all out, and you get a delta T of. I got a delta T of 0.95 degrees centigrade. So
you're making this sound so much easier than it was for me last night. I was sitting here for about an hour looking at it, and I think I just managed to get one dodgy formula out of it. It wasn't even the right formula. It sounds so much easier.
I had Bob helping me, the ultimate in physics tutors. So that's my excuse, and I'm sticking to it.
Very helpful.
So then question 3 was drinking a soda. That's practically the same as the first question. In fact, I worked it out using exactly the same formula as the first question. So again, the final temperature is going to equal the mass of the person times the temperature of the person plus the mass of the drink times the temperature of the drink all divided by the total mass of the person plus the drink. 0.355 litres is 0.355 kilograms. That's one of the beauties of the metric system. So again, we plug the numbers in, we work it out, and I got 36.87 degrees centigrade Celsius as the answer.
Perfect. Sounds fab.
And then question 5 was just, basically, could that be measured by a medical thermometer? I said yes, because if we're told the original temperature of the person is 37.0 degrees, they're now 36.87 degrees. High quality medical thermometer can measure temperature changes as small as 0.1. So yes, a medical thermometer would measure that change in temperature.
Genius, Jen. Thank you.
So that's it. Done. Dusted. I would think that that's possibly our last homework as well. I can't see that we'd be given a homework next week, seeing as is it next week that's effectively our last week? Yes, it is.
Yeah, off Friday.
So yeah, so I'd say that's the last physics homework as well.
Thanks a million.
Thank you.
Thank you so much.
I feel like you don't gain a lot from this, Jen. I feel that.
Yeah, we're the ones that gain, and you're just giving us the information.
Yeah, thanks so much. I struggle so badly.
It's I do look at the questions and think, oh my god, how do you work that out? But once you look at it, it's not too bad.
Yeah, thanks so much, Jen.
Thank you very much, everybody. Bye bye, and bye bye to the robot in the car.
Thank